Hey guys, it's Adam Chalasinski here, and we're here at the University of Cincinnati going over an electrodialysis stack water filter system sponsored by OMID through our sponsor Mosin Reside. So basically what we got here is what we're trying to work on is a solar powered water filter for rural applications. And so we're basically taking the straight voltage from the solar panel, about 19 volts, and splitting it across these membranes, 10 stacks of them, where basically you have a feed channel of your feed water solution being stripped by another channel of brine, which is pulling the ions towards the positively and negatively charged plates. So basically we also have pumps that are pumping from the bottom of both tanks and recirculating the water through the system and through a UV tube.
So we ran a couple tests in the lab to work out how much salinity we could remove from water. So we did tap water first, and we have the feed tank and the brine tank. So we put tap water in the feed tank and then deionized water in the brine tank. So we could see how much, basically we measure the salinity with conductivity. So we tried to see how much salinity we could remove from tap water and then put into the deionized water in the brine tank. So we have the results from our first experiment here. And it is the change in conductivity over time. And as you can see, there's a little spike at the beginning, but then over time we gradually get down to almost no salinity in the water. We got a final conductivity of 9 microsiemens, which is about on the same level with deionized water. And then on the second test, which we have here, we basically switched the feed and the brine tubing so that we were taking the brine water from the previous test and then repurifying it. So we started with a really high salinity concentration we had our conductivity for 1598 microsiemens, and then at the end of the test, over the same time period, we got down to 6 microsiemens. So once again, we drastically decreased the salinity of the water.